So we'll start by figuring out the dimensions of this right circular cylinder. Its volume is 9 pi, and it's pi r squared times h. The height is 3, so that's pi r squared times 3 is 9 pi. Drop that, 3. So the radius is a square root of 3 centimeter. So if I had to draw this, it would look something like that. That's root 3 centimeter, and that's 3 centimeter. And then we have this ball of diameter 4 centimeter, which means radius is 2 centimeter. So it's bigger than that. So it's probably going to look something like, it will be inside. So not a pretty drawing, but something like that. Question is the vertical distance from the topmost point of the ball to the base. So what I need to figure out is what's the kind of the drop, meaning you have something like that. And so if I'm drawing it as a circle, I need to figure out that distance here. So if I connect, so I'm kind of making a slice, and this is the circle that slice is part of. That radius is 2, that's 2. And we also know that the diameter here, which would be 2 root 3 centimeter, would be that chord length, 2 root 3. That means that length is half of that, or root 3. So I can figure that out, this right triangle, that distance here, let me call that x. And if I apply the Pythagorean theorem, actually it might be the 30, 60, 90 triangle, but that's okay. We can apply that. 3 is equal to 4, so x is equal to 1. So yeah, it is the 30, 60, 90 triangle. So that distance is 1, radius is 2, so that's actually 1. Again, not drawn to scale. And actually, we don't even need this part, because we can now find this distance, the top of the ball, that's 2 plus 1. So to the top of the cylinder, that's 3 centimeters, meaning up to this point to the top is 3 centimeters. And then we have the height of the cylinder, which is another 3 centimeters. So the total is 3 plus 3, or 6 centimeters, and that's the answer.